Mathematicians often speak of mathematics as a language. Some even call it the language of the universe. In spoken form, mathematics appears as the world languages we all know and love. Sure, there are some specific terms, but those can be easily looked up in a glossary. It is the written form of mathematics that is both unique and universal. The same characters, symbols, and methods are used worldwide and express ideas that transcend individual cultures and languages. Luckily, we can use our knowledge of world languages to help us better understand the language of mathematics. In mathematics, just as in any language, we start with our alphabet. Mathematically, this includes variables, letters that represent an unknown quantity, coefficients, numbers that multiply variables, exponents, superscripts that tell us to multiply 1 by the base a certain number of times, and constants, numerical values that stand alone. Combining these elements using multiplication or division will produce terms, the mathematical equivalent of words. Terms, connected by addition or subtraction, form mathematical phrases known as expressions. Expressions, like phrases, don't hold much meaning outside the context of a sentence. An expression like 2 plus 3 or 5x plus 7 gives us limited information, just like the phrases the red-headed girl or the pink dress. However, whenever we write a sentence, we provide more context for those ideas. In mathematics, sentences are created by linking two expressions using an equal sign or one of our inequality signs. And these types of sentences are known as equations and inequalities, respectively. An equal sign designates that two expressions have the same value, while inequalities express that one expression has a greater or lesser value than the other. An equation like 2x plus 3 equals 7 provides greater context for both expressions involved. In mathematics, as in life, our goal is to determine when statements are truthful. Now, we all know that not all statements are true all the time. For instance, if I just say Joshua is 6 feet tall, that is not true for every Joshua in the world. To find out where that is true, we'd have to go through all the Joshuas in the world and determine which ones are 6 feet tall. Now, the instances in which we have a Joshua who is also 6 feet tall are called our solution set. For example, the solution set for 2x plus 3 equals 7 is 2. This means that the only time the statement 2x plus 3 equals 7 is true is when x is equal to 2. Any other value will make the statement false. But how do we figure out the right values? Well, that's where algebra steps in, helping us to reconcile and reconnect the known with the unknown. Using everything that you've learned about mathematics so far, we are going to spend this course reasoning logically about the possibilities of the unknown.